Hello everybody and welcome back to another Algebra 1 video. Today we will be finishing up Chapter 9 with Lesson 9.5 on solving systems of linear and quadratic equations. Now previously we have solved systems of linear equations, and you might have learned 3 different methods for solving those. Those include graphing, substitution, and elimination. For today's lesson, we're going to be using those exact same methods, except this time our system is going to involve both a linear equation and a quadratic equation. For today's lesson, we will be using the substitution and elimination method. Before we try any examples, I just wanted to give a quick refresher on substitution. You're going to follow 3 basic steps in order to solve a system using substitution. The first being is that you want to solve at least one of the equations for one of the variables. So this just means that you want to make the equation equal to either x or y. It doesn't matter whichever you prefer. For example, maybe y equals to x plus 2 or x equals to y plus 3. These 2 equations can be used for substitution because they are set to an isolated variable. Step 2, you're going to substitute the expression from step 1 into the other equation and solve for the variable. So what that means is that you're going to take, for example, this x plus 2, and you can go ahead and substitute it into the y value of your other equation, then solve for x. I'll go ahead and show you that more in depth once we get into an example. Lastly, you're going to substitute the value from step 2 into one of the original equations and solve for the other variable. So let's say that you went ahead and substituted x plus 2 into the y value of your other equation, and then you went ahead and solved it and got that x equals 2. The next thing you want to do, which is the last step, is you want to substitute the value that you got into one of the original equations. It can be either one, whichever you prefer, and the purpose of this is so that you can find your other value, which in this case is your y value. So if you substitute x with 2, you get y equals 2 plus 2, and you get that your y value equals 4. Now remember that whenever you're solving a system of equations, your answer is going to turn out to be an ordered pair with one x value and one y value. So you want to make sure that when you're trying to find your solution, you're giving the complete answer with both an x and y value. Here is an example for us to try. We're going to solve this system using substitution. Our first equation is y equals x squared plus x minus 1, and that's going to be our quadratic equation. And our second equation is y equals negative 2x plus 3, which is our linear equation. Very first step you want to take when using substitution is you want to make sure that at least one of your equations equals to either x or y. In this case, both of our equations already equal to y, so we can just go ahead and substitute one of the equations in for y and solve for x. I'll go ahead and substitute negative 2x plus 3 into the y value of x squared plus x minus 1. If you do that, you would get negative 2x plus 3 equals to x squared plus x minus 1. And now you can just solve for x. In this case, we are working with a quadratic equation, so what we want to do is we want to make our equation equal to 0 and then go on from there to factor. So I'm going to try and get rid of my negative 2x plus 3 on this side of my equation by using inverse operations. First thing, I'm going to add 2x to both sides. If you do that, you would get x squared plus 3x minus 1 equals to 3. And now to make your equation equal to 0, you want to subtract 3 from both sides. Once you do that, you get 0 equals to x squared plus 3x minus 4. And in this form, you can now factor your quadratic equation. What you're looking for are 2 factors of negative 4 that will multiply to negative 4, and those same 2 factors should add to positive 3. So in this case, it would be -1 times 4, and then -1 plus 4. This case, -1 times 4 equals to -4, and -1 plus 4 would equal to +3. And then you can go ahead and factor your quadratic equation. It would be x minus 1 times x plus 4 equals to 0. And now you can go ahead and just solve each one of your binomials for x. So you can do x minus 1 equals 0, and also x plus 4 equals 0. This one would just be x equals to 1, since you're adding 1 to both sides. Then for this other equation, if you subtract 4 from both sides, you would get x equals to -4. So your two x values in this case would be x equals to 1 or x equals to -4. Now that you've found both your x values, you can go ahead and plug them into one of the original equations to find your y's. Now if you recall, in a system of linear equations, we only had one ordered pair, but when you have a system that has both a linear and quadratic equation, you're actually going to get two ordered pairs. So I just went ahead and chose y equals -2x plus 3 since I thought it would be easier to substitute and solve for y. And all you have to do is plug in -4 and 1 into this equation. So if I plug in -4, I would get -2 times -4 plus 3. This would just simplify to +8 plus 3, and 8 plus 3 just equals to 11. So your y value would equal to 11. Remember that you want to express your answer as an ordered pair with an x value and a y value. So when x equals to -4, your y value is going to be 11. You can do the same for +1. Go ahead and plug +1 into -2x plus 3. -2 times 1 would just be -2 plus 3. And then -2 plus 3 simplifies to 1. So your y value would equal to 1. And your final ordered pair would be 1, 1. So your final two solutions are going to be -4, 11 and 1, 1. Here is another system for us to solve using substitution. We have y equals -5x, which is our linear equation. It might look a little bit different because it doesn't have a y-intercept, but when you don't see a y-intercept value, it just means that the y-intercept is at 0. And then the second equation is y equals x squared minus 3x minus 3, which is our quadratic equation. Again, the very first step you want to take when using substitution is make sure that at least one of your equations is equal to x or y. In this case, both of our equations are already equal to y, so we can just go ahead and substitute one of our equations into the y value of the other and solve for x. I'll go ahead and substitute -5x into the y value of x squared minus 3x minus 3. If you do that, you would get -5x equals to x squared minus 3x minus 3. Once again, since we are working with quadratic equations, we want to make sure that we can be able to factor. So I'm going to go ahead and make my equation equal to 0 by adding 5x to both sides. If you do that, you would get x squared plus 2x minus 3 equals to 0. And now you can go ahead and factor your quadratic equation. You're looking for two factors of -3 that will multiply to -3, and those same two factors should equal to +2. So when thinking of factors of -3, it's going to either be positive or -1, and positive or -3. In this case, it would be -1 times 3, since that would equal to -3, and then -1 plus 3 would give you +2. Now that you've found your two factors, you can go ahead and factor your quadratic equation into your two binomials, which would be x plus 3 times x minus 1, and that would be equal to 0. Now you can go ahead and set each of your binomials equal to 0 so that you can find both your x values. So you can set x plus 3 equal to 0. You can also set x minus 1 equal to 0. And now all you have to do is do inverse operations to solve for x. In this case, you would just subtract 3 from both sides, and you would get x equals negative 3. And then you would add 1 to both sides for x minus 1. And that would leave you with x equals to 1. And those are your two x values for your system. Now that you found your two x values, you can go ahead and plug it into one of the original equations to solve for y. I'm going to go ahead and use y equals negative 5x since I figured it would be easier to solve. But you can also use the quadratic equation that we were given if you'd like. And now all you have to do is substitute both negative 3 and 1 into y equals negative 5x. First, I'll plug in negative 3. Negative 5 times negative 3 just equals to positive 15. So your y would equal to 15. And your final ordered pair would be negative 3, 15. You can do the same for positive 1. Plug it into y equals negative 5x. Negative 5 times 1 just equals to negative 5. So your y value would equal to negative 5. And your final solution would be 1, negative 5. So your two final solutions are those two ordered pairs that we just got. Now we're going to be moving into elimination. Here is just a brief refresher on the steps of elimination. Step 1 is to multiply, if necessary, one or both equations by a constant, so at least one pair of the like terms has a coefficient with the same number but opposite signs. So for example, you might have negative 3x and positive 3x. Those would be good since they would be able to eliminate one another. Step 2, you're going to add or subtract the equations to eliminate one of the variables. And step 3, you'll go ahead and solve that resulting equation for the remaining variable. And lastly, substitute that value that you solved for in step 3 into one of the original equations and solve for the other variable. And that last step is the exact same as what we did in substitution. I'll go ahead and show you elimination with this system example. We have y equals x squared minus 3x minus 2 for our first equation, and this is our quadratic equation. Our second one is y equals negative 3 minus 3x minus 8, and that would be our linear equation. First thing you want to do is you want to multiply at least one or even both of your equations by a constant so that you can eliminate one of the like terms. You have freedom to cancel out whichever like term you would like. I went ahead and decided to cancel out the 3x's. In this case, we see that both of our 3x's are negative, so I would multiply one of the equations by negative 1, so one of them could be positive. I went ahead and multiplied y equals negative 3x minus 8 by negative 1, and make sure that whenever you're trying to multiply by a constant, that you are multiplying the entire equation, including what it's equal to, in this case y. If you multiply it by negative 1, you would get negative y equals to positive 3x plus 8. Now you can bring down your other equation, which is y equals x squared minus 3x minus 2, and go ahead and eliminate any of your terms. In this case, y and negative y would cancel, and then our 3x's would also cancel. So now all you have to do is solve for the remaining equation. So since our y's canceled, it would be 0 equals to x squared, and then 8 minus 2 would just be 6. So our remaining equation would be 0 equals to x squared plus 6. Now you can go ahead and solve for x. First thing I want to do is I want to subtract 6 from both sides so that we can isolate x. And you would get negative 6 equals to x squared. However, there is a problem since you cannot take the square of a negative number. So since you can't do that, we know that the system will have no real solution. Let's go ahead and take a look at this other system, which we'll also solve using elimination. We have y equals 9x squared plus 8x minus 6, and we also have y equals 5x minus 4. I'm going to go ahead and cancel out the y's since I don't want to multiply both of the equations by a constant. So I'll go ahead and multiply one of the equations by -1 so that we can cancel out our y's. I went ahead and multiplied y equals 5x minus 4 by -1. If you multiply that, you would get -y equals to -5x plus 4. And then go ahead and bring down your other equation, which is y equals 9x squared plus 8x minus 6. And now you can go ahead and eliminate. Y and -y would cancel each other out, and you can solve for your remaining equation. So since your y's cancel, you would get 0 equals to 9x squared. And now you can just combine like terms. 8x minus 5x would give you positive 3x, and -6 plus 4 would give you -2. So your final resulting equation is 9x squared plus 3x minus 2. And now that you have a quadratic equation that you got here, you can go ahead and solve for x by factoring. In this case, our a value equals to 9 and not 1, so we're going to have to use the AC method to factor. The way this works is we're going to go ahead and first multiply a and c. So in this case, a times c would be 9 times -2, and that would give you -18. You want to find two factors of -18 that will add up to your middle term, which is positive 3x. So when thinking of factors of -18, one of them has to be negative. So we can have positive or -1 and positive or -18. That wouldn't work, so go ahead and keep listing out your factors. Positive or -2 and positive or -9 also wouldn't work. So we can move on to positive or -3 and positive or -6. This would actually work if we multiply -3 by 6, we would get -18. And if we add -3 plus 6, that would give us positive 3. So we know that these are the two factors that we want to use. And what you're going to do with these two factors is you're going to replace your 3x with -3x plus 6x. So this is what it would look like. You would have 9x squared minus 3x plus 6x minus 2. And now notice that if you were to just simplify this and combine like terms, it would still be 9x squared plus 3x minus 2. So these are still basically the same exact equations. But now what you want to do is you want to group your first two terms and then your last two terms. When you are grouping your two terms, I do recommend that you try to group two terms that you know will share a greatest common factor. So in the case of 9x squared minus 3x, you can do GCF factoring and factor out a 3x. If you factor out a 3x, you will be left with 3x minus 1 inside the parentheses. And then as for 6x minus 2, the greatest common factor would be 2. And then if you factor out a 2, you would be left with 3x minus 1. And notice that the expression inside the parentheses is the same. So that's going to be one of the binomials for your final factored form. And then the other one is going to be made up of the two factors that you factored out, or your GCFs. So final factored form would be 3x plus 2 times 3x minus 1. And remember that this does equal to 0. So now that you found your factored form, you can go ahead and set each of your binomials to 0 in order to find your x values. So this would be 3x plus 2 equals 0, and also 3x minus 1 equals 0. To solve for x, first subtract 2 from both sides here. That would give you 3x equals to negative 2, and go ahead and divide both sides by 3 to get that x equals to negative 2/3. Do the same for 3x minus 1. Add 1 to both sides. That would give you 1 equals to 3x. Then you can divide both sides by 3 to isolate x, and you would get that x equals to 1/3. And those would be your two x values. Now that you've found those, let's go ahead and substitute our x values into one of the original equations to find our y's. I went ahead and chose y equals 5x minus 4, but you can go ahead and plug it into the original quadratic equation if that's what you prefer. And I'll go ahead and plug in both negative 2/3 and 1/3 into this equation so that we can get both our ordered pair solutions. If I plug in negative 2/3, 5 times negative 2/3 would be negative 10/3 minus 4. And now you would need to make a common denominator. So I'm going to go ahead and multiply negative 4/1 by 3/3 so that we can have a common denominator of 3. That would give you negative 10/3 minus 12/3. And all you have to do is simplify. Negative 10 minus 12 would just give you negative 22/3, and there is your y value. So your final solution or ordered pair would be negative 2/3 and negative 22/3. Do the same for positive 1/3. Plug it into y equals 5x minus 4. So if you plug in 1/3 for your x value, 5 times 1/3 would give you 5/3 minus 4/1. And again, you need to make a common denominator. I'm going to do the exact same thing and multiply 4/1 by a factor of 3/3 so that I can get a common denominator of 3. That would leave me with 5/3 minus 12/3. 5 minus 12 is negative 7/3, so your y value in this case would be negative 7/3, and your final ordered pair would be 1/3 negative 7/3. And those are your two solutions for this system. That is it for today's lesson. Thank you so much for watching. Please make sure to subscribe and like this video if you enjoy the content or find it helpful. I really appreciate your support since I try to create my content for students to easily access for free and be able to thrive in the classroom. As always, all information regarding additional practice, tutoring inquiries, and lesson requests can be found down below in the description box. If you have any questions about anything that I teach in these lessons, feel free to contact me at kaylin.david24@gmail.com, and I will try to get back to you right away. Again, thank you so much for watching, and I hope to see you in the next video.